So we're starting 4-1, and we're starting with very basic an angle. So trigonometry is the study of triangles, and in order to make triangles, we need angles. So angles are formed by two rays, and they share a vertex. We'll just say two rays that share a vertex. I'm going to need this calculator in a little bit, so I'm just going to keep it up with us. Angle is formed by two rays that share a vertex. So to remind us about what you learned like day 2 of geometry, so I know that you've slept between now and then or blacked it out of your memory, a ray is formed by a point and then an arrow on the other side. So it stops in one direction, but then goes on and on forever in the other. And so I've got two rays, I've got 2 points, got 2 arrows going in opposite directions. This is also a ray. And then the point that they connect at is my vertex. And the vertex, what I tell geometry students is like where the angle actually happens. So like the angle is actually like in here. Now, when we learned geometry, all of our angles were acute, right, or obtuse. They were 180 or smaller. They were always like inside the 2 rays. I would say this is the interior of the angle, the other part's the exterior. Now that we're adults and in pre-cal, or almost adults for some of us who aren't there yet, we're going to go all the way around sometimes. So the angle could either be like what's on the inside, or it could be the distance around the outside. So we're kind of thinking about angles, not just like the small part in between the rays, but it could go from like one ray all the long way around to the other side. So that's kind of just a hint and a helpful show that like angles aren't necessarily all that we thought them to be. They're going to look a little different now. Okay. Standard position. Standard position is kind of like the grown-up way. We're also going to look at angles in a second, and it's on an XY or axis or coordinate plane, however you want to call it. When we did geometry, we did angles just kind of like wherever we wanted to put them in space. They were just all over the place. When we do standard position, they're going to be in a very like specific way. We're going to look at this more later, but I do want to introduce it while we're here at the beginning, just talking about angles. So let me draw. That's like your X and your Y axis. Y, X. Okay. Your vertex of your angle is always going to go on the origin. So in standard position, your vertex is where your origin is. So 0.00. One of your rays is always going to go on the positive X axis. It's just going to lay nicely right here. One of your rays will always lay right there. I think we call that like our initial side. I think we'll go more in depth on that later, but one of them always stays on that side. And then the other one rotates around like clock hands. And so it can be in this nice, pretty, like in the first quadrant and make a nice, pretty, like acute angle, like we're used to seeing, kind of like the one up top. So I've got this nice little acute angle. However, I just said it moves like a clock hand, so it can keep going around and around. So instead of just being here, this nice, pretty acute angle, it also can go like over here into the like second quadrant, and that would make this more of an obtuse triangle. Whoa, what happened there? So bigger than 90. It's an obtuse angle. But even more than that, it can go into like the third quadrant, where I know mine is super busy, or the fourth quadrant. When it's down here, we're not necessarily concerned with this distance here. No, we're concerned going all the way around the long side. We're not going to get into too much of this today, but I just am trying to expand our minds and recognize that like angles are not all that we thought they were, and they can be bigger than 180. And they also can be bigger than 360. So we're just kind of do some of those like, I guess, misconceptions with angles as we go along through this. But standard position just basically by definition means this. Okay. right, let's talk about radians and degrees now. Now, I don't know if you guys talked about radians in Algebra 2. I thought last year or the year before, I talked to the Algebra 2 teachers about like bringing it up to you guys. So it wasn't brand new when you saw it with me, but I don't know if you guys have seen it or not before. Degree is something we know. Like we know how to measure angles in degrees. I know this might be kind of silly, but I like to think of like, oh, I know this word. Like we know how degrees work. If you want to get a little protractor out, that's measured in degrees. Generally, all the triangles we've ever measured have been in degrees, 90 degrees, 50 degrees, 170 degrees. Like we know what degrees are. Radians is another like unit to measure angles in. Another unit of measure, I'll say, for angles. And I'll zoom out so you can actually read this in a second. It's another unit of measure for angles. Like degrees have like a little like O above it, like when we think about temperature or whatever. Radians don't really have a mark. They are usually in terms of pi. There's a lot of pi's in them, and often we leave them in fraction form, and you'll understand in the next few days or weeks why we leave them in fraction form more. While I'm talking about degrees and radians, I'm going to give you a couple conversion factors. Maybe I'll prove this out tomorrow, but for sake of time for today, and just because I'm going to throw a lot of other information, so I don't need to show you something that you don't need to know or replicate for me, I'm going to show you the like formulas, I guess, or the conversion factors of how we switch between radians and degrees. So if I have radians and I want to go to degrees, we're going to take my angle measure and we're going to multiply it by 180 over pi. If I'm going to do the opposite, if I'm going to go from degrees to radians, I'm going to take my angle measure and multiply it by the reverse, pi over 180. Now, truthfully, I don't sit outside of trigonometry time and be like, oh, I remember exactly degrees to radians is this and radians to degrees is that. What I do know is that when I look at these two together, 180 degrees is the same thing as pi radians. I don't know if I have any more room to write this. Pi radians. So if you know 180 is the same thing as pi radians, that can help you know that's the conversion factor. And then we'll do a couple examples in a minute, but like a radian always has pi in it. I think I just mentioned that a second ago. Radians have pi in them. So to get rid of the pi that's in them, we're going to divide by pi in order for those to cancel out. Again, we're going to come back to these in a second. So I'd maybe like highlight them or put a big box around it to help me. Ooh, that's not what I wanted to do. To help me remind myself that these are important, I will come back. Now, before we can do radians to degrees, we also need to kind of expand our knowledge of degrees. Underneath degrees, you see the words minutes and seconds. This is kind of like navigation stuff. So like when people do navigating and like if we're doing problems about like boats or the sea or airplanes or something, they use like degrees, minutes, seconds to measure that. Basically, think about like in our normal life, we know seconds and minutes. We usually refer to those as time. If you think of degree relates to minutes and seconds, like an hour relates to minutes and seconds, that kind of helps me keep things straight. Minutes and seconds are like the decimal part of a degree. So the degree is like the whole number and minutes and seconds are like the decimals. If you think about half an hour is like 0.5 of an hour, or sorry, 30 minutes is the same thing as like 0.5 of an hour. So like we talk about minutes and seconds, and we could also talk about it in terms of hours by decimals. So that's the same thing here with minutes and seconds in degrees. I wish I could tell you who came up with this and why. I don't know. And I don't love this part of the unit, but I have to teach it to you. And it's also not that difficult, but we need to kind of struggle with it for a little bit. So now that I told you that degree is in like reference to hours to minutes and seconds, I think that helps us keep in line what we can convert by. So like if I'm thinking about minutes to hours, I know in like 1 hour, there's 60 minutes. I left a big blank after one because I'm not going to write hour because I'm not talking about hour. I'm going to write degree because that's what it is in math terms. That's what it is in trig. That's what it is right now. So in 1 degree, there are 60 minutes. We can also think about it in terms of seconds. In 1 minute, and again, we can think of this in time like we're used to. In 1 minute, we know that there are 60 seconds. That's the same thing as it is with angles in minutes and seconds. But sometimes I don't want to go from seconds to minutes and then minutes to out to degrees. So let's think about, is there 1 degree is how many seconds? One minute is 60 seconds. And then 1 degree is 60 minutes. So in order to go from degrees to seconds, I'm going to do 60 times 60. So in 1 degree, there are 3,600 seconds. And that's also how many seconds there are in 1 hour. Not that that's something we like generally use or know as much as we know 60, but not hard to get there. We did 60 times 60 to get there. These are, again, little conversions that we need to know. So I'm going to box, box, box. Okay. And then there's one other thing we need to know before we move on, and that's arc length. And we'll just barely look at that today. Arc length is like the crust of a pizza or a pie. It's like if I'm looking at a piece of pizza or like what looks like a piece of pizza in a circle. The arc length is like this part right here. It's that curved distance from where the radiuses connect to the sides of the circle. That's my arc length. That's my pie crust. You cannot measure that like we're used to measuring it. We also can't do like a little triangle because like this isn't a triangle. It's a straight side, and then it's a curved side. So that doesn't follow the rules of triangle. So we've got some other like ways we need to think about it and mathematic equations in order to solve for that. So arc length is like the crust. And I'll give you the formula while we're here just to keep it all in order. I did not for the other class. They'll probably be mad when they go watch this later. But the formula for this will be S equals R. And then this thing that I just drew is called a theta. S is my arc length. I know I'm writing teeny tiny and messy, but S is my arc length. And then R is my radius. And then this guy right here, what I just said was it's called theta. If you've ever been like on Greek row at any college or university, theta like is often used in different fraternities and sororities names because it's just a Greek letter. Theta in math references to angle measures. So we're going to be using theta a lot from now on. I don't think I've ever used it with you. I don't know if I showed it to you in geometry. I doubt you would ever see it in algebra for any reason. So that's theta, and it means like my angle measure. And in this case, in arc length, it's got to be measured in radians. I hope to get to that before we're done for today, but That's not what we're dealing with right now. We'll deal with it in a few problem sets. But arc length is S equals R theta, and that theta means angle measure in radians. Any questions so far? I know I've just thrown a lot at you, but all we're doing right now is conversions. We're just converting from one form to another, from one form to another. So we're going to go and we're going to start solving some of these problems out. We're going to be really careful with our decimals and with our fractions and all that fun stuff. And there's not a lot of room to write. So I'm going to try and write carefully and neatly, but we're just going to be patient and try our best. Any questions so far? Okay, this first one says we're converting from DMS to decimal form. DMS is this degree, minutes, seconds. So right now I gave it to you in degree, minutes, seconds. I've got a degree 136. My minute is that first apostrophe is 1 apostrophe, and then seconds is 2 apostrophe. Kind of like how we represent feet and inches. I'm not really sure who decided why we were allowed to use those things for different things, but they did, and we're going to keep using them. Now, minutes, I need to get in forms of degrees. So it's going to be a decimal. If I've got 10 minutes, that's a decimal of some degree or some hour. Like if I said it's going to be in 10 minutes, you wouldn't say, oh, that's 60 hours. It would be like a decimal of an hour. In order to find it, we have to be really careful of our units. So I've got 60 minutes, and I'm not great with the apostrophes and the degree, so I like to physically write my unit with it so I don't get it confused. I've got to divide it by the amount of minutes because I need to make sure my minutes cross out and then I'm left with degrees. My conversion fact from above was that in 1 degree, there are 60 minutes. So I'm doing 1 degree divided by 60 minutes, so my minutes cross out from each other. Because I said 1 degree equals 60 minutes, we could do either way. We could have degrees on top or minutes on top. But in this problem, I want degrees on top because the minutes need to cross out. So it has to be on the bottom. That means I can just straight divide. I've got 10 times 1 and then divided by 60. So I'm just going to do 10 divided by 60. And I get 0.16666666667. So point, and I'll just put a handful of sixes and then deal with that in a minute. Also, I found this calculator on my iPad. I don't know if I downloaded it or if it was already there, but the one that I was using on my computer screen went away after I did an update. So I got to figure that out, but it's a me problem and it's not a today problem. So I'll deal with that later. So for now, you can see my calculator on the side of my screen. Now we have to do our seconds. So now I need to make 14 seconds in terms of a decimal too. So I'm going to do 14 seconds. And I'm going to do a conversion factor where seconds is on the bottom and degrees is on the top. And as we remember, we talked about how 1 degree is equal to 3,600 seconds. So I'm going to do 1 degree divided by 3,600 seconds. So it's like 14 times 1 divided by 3,600. 14 divided by 3,600 is going to be another kind of crazy decimal, 0.003888889. 0.0038889. Now, both of these are decimals of a degree, so we have to add them together to get what my whole decimal is. Don't forget that the degree didn't change. We did not do anything to 163. If I tell you we're like class is going to be an hour and a quarter, we're not going to do anything to that hour. We're going to keep the hour the same, and we're just going to see what all the decimal behind it will be. So I'm going to add my 0.16667 and then my 0.0038889 together. You can put as many sixes in there as you want. And I would generally round to 4 places. That's a very safe place to round, 4 places. So I'm going to say it's going to be 0.1706. And that answer is in degrees. Any questions so far? All right, we're going to do another one. Same idea. Going to make my minutes into a decimal, make my seconds into a decimal, add them together. So let's go do that. Nope, I don't want that color. So 16 minutes. We're going to multiply by 1 degree over 60 minutes because my minutes have to cancel out. 16 divided by 6D is 0.26667. Then I have to do my seconds, which is going to be 29 seconds. And I'm going to do 1 degree over seconds, which is 3,600 seconds. So I'm going to do 29 divided by 3,600, which is another crazy decimal, 0.00805556. And then I'm going to add those two together to find the whole decimal. Don't forget the degree stays the same. We don't do anything to him. So it's going to be 93.2747 degrees. Anybody questions so far? All right, because we're about to do the opposite now. We just went from degrees, minutes, seconds to decimal. Now we're going to go backwards. I'm going to give you a decimal. We're going to put it in degrees, minutes, seconds. Can I move on? Okay.
Yeah.
Thank you. I love when you guys respond. It makes me feel more involved with you. So thank you. Decimal needs to go into degree, minutes, seconds. This is a degree. 0.74 is a degree. So now instead of multiplying by 1 degree over 60 minutes, I'm going to multiply by the reciprocal, 60 over 1. 60 minutes over, stop. Is this how today's going to go? Sorry. I'm just threatening the notability. You guys are fine. 0.74 degrees times times 60 minutes over 1 degrees. Again, the degrees have to cancel out this time. So since my decimal is in degrees, I've got degrees has to be on the bottom. Instead of doing 0.74 divided by 60, I'm doing 0.74 times 60. Remember up here, all of our things, our minutes and seconds were both in whole numbers. So that's what my minutes and seconds are going to be here. When I did 0.74 times 60, I get 44.4. Now I literally just got done telling you that it needs to be a whole number. This decimal is okay. We're going to need to make that decimal of a minute into whole numbers of a second. Our answer in this case is going to be our 103 degrees, some amount of minutes, and some amount of seconds. We just found the amount of minutes we have, that's 44. And then to find seconds, I'm going to do 0.4, that's in minutes. We just found this is in minutes. We're going to do 0.4 minutes times, and this time it's 1 minute has to be on the bottom. And then how many seconds are in 1 minute? 60 seconds. Before we were dividing, now we're multiplying in order to get rid of my units. In here, we do that in between step to minutes before we go to seconds, just because we need to know what the decimal is for minutes. When we go from seconds, we can go directly to degrees, but we can't go that the vice versa. So when I do 0.4 times 60, I get 24. So 24 seconds is my answer. 103 degrees, 44 minutes, and 24 seconds is our whole answer. All right, similar for the next one. We're going to do the exact same thing. Do the decimal times 60, and then if we get a decimal on that, multiply that decimal by 60. See how I left the whole number though? So like I didn't do 44.4 times 60. I only did the 0.4 times 60. That's a common mistake that sometimes happens. All right, here I've got 0.77. So let's do that. 0.77, that's in degrees. So I'm going to multiply by 60 minutes over 1 degree. Again, you can use a little circle. Sometimes that makes me think it's a 0. So that's why I've been writing out degrees, but whatever floats your boat. 0.77 times 60 is going to be 46.2. Okay, so I knew I had 18 degrees. That doesn't change. I have 46 minutes though, because I just solved that. Why is that so messy? And then now we're going to do our 2 to find our 0.2, excuse me, to find out how many seconds we have. This is 0.2 minutes, and so I need to go from minutes to seconds. In 1 minute, there are 60 seconds. And so 0.2 times 60 is 12. Now, I am not great with conversions personally, so like that's why I sometimes fill in like the denominator before I fill in the numerator. So if you need help, if you're struggling with conversions, let me know. I don't think they're the hardest, but sometimes like if you don't know which goes on top and bottom, we can talk through it so you kind of have better strategies as you go. When I found this in degrees, minutes, seconds, 18 degrees stays the same. My minutes is 46, my seconds is 12. Okay. Any questions, any comments, any thoughts? Okay, you guys are doing great. We're gonna go down and do 3 and then 5, and then we'll come back to 4. So we're gonna skip 4 for a second, but we're gonna do 3 and then 5 because those are similar. Now, number 3 says convert to radians. So it's not degrees, minutes, seconds like we've just been doing. It's just normal degrees to radians. So I'm gonna go back up to my yellow box at the top, and I'm going 2 radians. So I have a degree, I'm going 2 radians. So I'm using my pi over 180. I'm going to multiply by pi over 180 on all of these. Some of you might be thinking, how do you know whether it's pi over 180 or 180 over pi? The easy answer is that radians will have pi in them. So 70 does not already have pi in it. It's a degree. Doesn't already have pi in it. So I need pi to be in my answer. So I'm going to multiply by pi over 180. Now, I want this to be left as a fraction. Unless I say put it as a decimal, assume that I want it as a fraction. And you'll understand either next class or 2 classes or a week from now why I want that, but you'll get soon why I want them all as fractions. So you can make it 70 over 1 if you want, and we're going to simplify as much as we can. So I see a 0 in both of them, so that goes away. Then I'm left with 7 and then 18. Well, 7 and 18 have nothing in common. So the best answer here is going to be 7 pi over 18. That is my best answer for an angle measure in radians. Radians are often decimals, or sorry, are often fractions. They can be decimals if I ask, but not unless I ask. And they have pi in them. So be comfortable or start learning to be comfortable with pi's and fractions. All right, same idea for the next one, 120. I've got 120. I'm going to multiply that by pi over 180. Again, I got to get pi in my answer. I have degrees. I got to get rid of it. And think of it as 120 over 1. I do know 120 and 180 both have a 0 in them. If you struggle with factoring out 2, let me know, or finding like what the smallest thing that they can reduce and simplify to be. I look for the zeros and then I see what else I can take out. If I knew nothing else I could take out, I'd probably rewrite it. So I'd have 12 pi over 18. And then now I can look and I see, okay, 12 and 18, I do know that. They both have a 2 and they both have a 3, which means the biggest thing I can take out of is a 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. So my best answer for this one is going to be 2 pi over 3. Any questions so far? Okay, again, we're going to skip number 4. We're going to come back to it, but let's go skip number 4 and let's do number 5. This one says convert from radians to degrees. That means we're going to do the opposite. So we were just multiplying by pi over 180. Now we're going to multiply by 180 over pi. I don't know if I've said this to you guys yet, but I don't often know what the conversion is, but if I know 180 and pi go together, if I have a radian, I don't want pi to be in my answer, so that helps me know that pi needs to go in the bottom, in the denominator. And then that helps me know, okay, this one is where I do 180 over pi. If I need pi in my answer, pi needs to go in the numerator. That's why on the last one I did 180 over pi, or 90 pi over 180. Sorry, words are a lot today. Again, I want this in a fraction as long as possible. So I've got my pi's cross out. I also can do 10 and 180. So the 10 crosses out and I'm left with just 18. So this is like 9 times 18, which I can do that in my calculator. I don't want you to do the decimals in the calculator for this one at least, but we can multiply 2 numbers in our calculator. So that gives me 162 degrees. Same thing for the next one. If you're feeling good, try it on your own. If not, wait a second for me. Seven pi over 9. I am going to simplify that. Or sorry, I'm going to multiply by 180 over pi. I can't simplify 7 pi over 9, but I can simplify here. The pi's cross out. And then 9 and 180 have a common factor of 9. So 20 times 9 is 180. Again, you can do 7 times 20 and then just write that down, but I've got a lot going on. So I'm going to remind myself, okay, I got rid of everything else. All I'm left with is 7 times 20. So I'm going to do 7 times 20 and get 140. I don't know why I did that in the calculator. That was embarrassing. I know that. Okay. Let's flip over to the next side and do C and D, and then we'll come back to number 4. So I'm sorry if you're on paper and you're flipping around a lot, but let's do C and D. Since these do not have pi's in them, I'm going to put this in a decimal form just because they don't already have pi in them. So I'd rather get rid of that. It's still a radian though, because it still follows under the same directions, convert from radians to degrees. And it also doesn't have a degree up here. So there's no degree sign with here. So we assume that it's a radian. And again, with radians, we always divide by pi. So I've got 180 divided by pi. If we didn't do a calculator, it would be 180 times 3, which is 540 over pi. But if you're like, okay, this angle is 540 over pi degrees, I'd say that's nonsense. Give me an answer that actually makes sense. Since there's no like other things to simplify, we can put this in the calculator and do 540 divided by pi, and we'll get out a decimal, and that's okay. This is going to be 171.873. And it's degrees. Questions? One more like this. It's going to be another messy one, but that's okay. Again, there's no degrees behind it, so we know that we're going to treat it like it's a radian, 180 over pi. If I were to just straight multiply 1.6 times 180, we would get 288 over pi. And then if I divide that by pi, I get 91.6732 degrees. All right, any thoughts so far? Okay, why don't we go back to number 4? I know, I'm sorry, I'm having you skip around a lot, but let's go back to number 4, the one that we skipped. We need to make that go from degrees, minutes, seconds to just normal degrees in decimal form, and then make that go to radians. So we've got a couple steps in here to do. So think about first how you want to make that degrees, minutes, seconds into a decimal. I'll undo the cross because we're going to actually do it. So 12 minutes. Again, I'd be super careful about your units because that helps me know what goes where. So 60 minutes goes on bottom, and I want 1 degree on top. 12 divided by 60 is 0.2. Oh, and there are no seconds. So that's my answer as a degree in all decimals, so 73.2. That's just step 1. Any questions on that? Okay. Now I need to multiply by my conversion factor to get it to radians. I'm going to multiply it by pi over 180. It's a degree, so to go from degrees to radians, we multiply by pi over 180. Now, you can leave pi in your answer or you cannot. Since it says use the calculator, I'll take either way. I like pi to be in my answer with radians, but I also understand the idea of like, well, if it's already a decimal, let's just multiply pi by it. So I get both ways, and I will try to make sure that I'm like either lenient on a quiz or a test or like very sure and tell you exactly what I'm expecting. If you want to leave pi in the answer would be 0.4067 pi. And if you want to include pi as part of it, then I'm going to multiply that times pi, and I'm going to get 1.2776. Either answer is correct, is fine. I guess most of us are probably most comfortable going all the way down to decimal form instead of keeping it like decimal and a pi, but either is fine. Either is fine. All right, questions? Same idea for the next one. This time I have 2 pieces, though. I've got to make both my minutes and my seconds into decimals. So I'm going to do it kind of over here, so I've got some space. So I've got 18 minutes. And so that's the same thing as 60 minutes on bottom and 1 degree on top. So 18 divided by 60 is going to be 0.3. That was easy. But I also have seconds here, so don't forget about your seconds. Now I have to do 51 seconds times 1 degree on top, and then my seconds on the bottom, which is 3,600 seconds. 51 divided by 3,600, which is 0.014167. The whole reason we found both of those is now we need to add them together to put on attached with my degree. So I've got 190 point. I'm going to do my decimal 0.0141. It's still in my calculator, and I'm just going to add 0.3 to that. So it's 190.3142 if I round it correctly. So I know that was a lot of work for the first step, but the first step was to go from degrees, minutes, seconds to just normal degrees. And now my second step is to go from degrees to radians. So I'm going to multiply by my conversion by pi over 180. Again, if you want to leave pi in your answer, I'm just going to do my 190 decimal divided by 180. And so if I kept pi in my answer, it'd be 1.0573 pi. And if you decided to multiply pi through that, it would be 3.3216. Ooh, that's the whole first page. Any questions so far? Okay. The other class just did one more problem, so we're just going to do one more problem, then we're going to call it a day. I don't know about you, but I'm feeling tired. Number 6 says a 100-degree arc of a circle has length of 7 centimeters. What is the radius of the circle? So we got to remember earlier on the top page where I talked about arc length up here. So I'm going to kind of draw that and go over that again very quickly. That is an eraser. I do love drawing circles on Notability, so this has been fun. I've got my circle, and I've got, let's say this is the middle. As good as that's going to get. It says it's a 100-degree arc, and it has a length of 7. So it's 100 degrees, and it has length 7, and then I'm looking for R. If you remember, my formula that I gave you earlier was S equals R theta. S is my arc length, so that's 7. So I'm going to say 7 equals, R is radius. Well, we don't know what that is, so I'm going to keep it as R. And then theta means my angle, but it means my angle in not degrees, but in radians. So I'm going to have to go figure out what 100 degrees is in radians, and then I'm going to plug it in here. So I'm just doing it off to the right side where there's some extra space. So I've got 100 degrees, and I'm going to make it a radian. Just for consistency, I want it to be as a fraction, and then we'll make it a decimal at the very end. So I want you to keep this as a fraction. So I'm going to multiply by pi over 180. I've got my zeros cancel out, so now I've got 10 over 18, 10 pi over 18. Again, you could have simplified all at once, but sometimes that gets messy for me. So 10 and 18 actually have a common factor of 2 still. So if I divide 10 by 2, I'm left with 5. And if I divide 18 by 2, I'm left with 9. So I've got 5 pi over 9. That is what I'm going to go plug in over to my equation over there on the left. 5 pi over 9. In order to get R by itself, I just think the easiest way is to multiply by the reciprocal. So I'm going to do 9 over 5 pi multiplied on both sides. The 9's cross out, the 5 pi's cross out. So I'm left with just R on the right side. And then on the left side, if I'm going to keep it in this fraction form for right now, it would be 63 over 5 pi. But that doesn't mean anything to me. So if you were like, my radius is 63 over 5 pi, I'd be like, I don't know what that means. So if we're going to make it a decimal, first we got to be super careful with it. So you can do one of two things. What I would probably do is do 63 divided by, and then I'm going to put parentheses on the bottom to keep my 5 and my pi together. If you do not have parentheses, your calculator is going to read it as 63 divided by 5 times pi. So we have to keep the 5 pi together. So when I do that, I'm going to get 4.0107. The other way you could have done it was just done 5 pi separately and then done 63 divided by that number. That would give you the same thing. If you got something else, then it took it as 63 divided by 5 and then times that pi. I don't think I told you if this was inches or centimeters or all that stuff, so we're just going to leave it as 4.0107. Oh, centimeters. We'll do centimeters. It did tell us. Centimeters. All right. I threw a lot at you guys today. Are there any questions? Any thoughts? Okay, I do not see you for 2 days, but I want to get all of the rest of this done and hopefully into 4.2 next time I see you. So if you have any questions or any thoughts, see me outside of class. Be prepared at the very beginning of class to ask questions because I want to try and get through this so I can get into 4.2. 4.1 is not as fun, I promise. I think it just gets so much more interesting and so much better in a couple lessons. So we got to get through this and into some better stuff. If there are no more questions, I'm going to stop the share.